I'm Brian Meadows. I'm the Executive Director of the Center for Future Innovators. Joining me today is also board member and head robotics coach, Tim He. And I have Ren Lee joining us today as a guest. She is our chairperson and co-founder of the Center for Future Innovators. So in our session today, we will be learning about our robotics program, and we'll be answering any questions you have about what students are learning in robotics and just anything about robotics in general. All right, next slide. So we are a Chicagoland non-for-profit with a mission of preparing future innovators through our positive youth development programs. Our goal is to help students find and nurture their passions. We also partner with the corporate 4-H sponsor, Cornerstone Education, to run the Chicago 4-H International Club. We established this club in 2017, and the National 4-H Council recognized us and nationally chartered us in 2020. Our project-based learning programs in STEAM, career development, college planning, and civic engagement are designed to prepare the next generation of students for success. So here's our team, and today we are going to be talking about these different, next slide. So the main topic today that we'll be covering is why learning robotics is so popular. We'll learn what separates a robotics program from a coding program. When should kids start learning robotics? And we'll learn what competitions students can participate in, how you prepare for these robotics competitions, and then we'll have a Q&A. And we have a couple of fun announcements that came in today. We'll do at the end of our talk. So definitely stick around. So while there are a lot of different robotics programs in our communities, most of them don't focus on how students can expand their knowledge and build their experience. What I mean is there's a huge gap between what students are learning in their elementary school and middle school robotics programs compared to joining robotics at high school. If you step into robotics and your first day of robotics is in high school, you're going to be at a strong disadvantage. Our goal is to provide a pathway for these students to compete at the higher levels and eliminate that gap. So let's take a look at why learning robotics is so popular. So our robotics, it's very cool and we learn a lot in it. But there's something that Lego created themselves to help highlight the importance of learning robotics and what skills the students can build. And here it is. These are the 21st century skills that Lego, robotics, and us all agree on, that these robotics programs are building for you. It's creativity and divergent thinking, critical thinking and problem solving, collaboration and teamwork, confidence and resilience. When I say creativity and divergent thinking, I mean creating your robot, finding a different way to solve these sorts of problems. We'll talk more in detail about the kinds of robotics competitions we'll be looking at, and we'll get more information with that from our head coach, Tim He. But these are very comprehensive programs where students can truly learn and practice their 21st century skills. They're building that critical thinking, that problem solving, and they work together. Most of these competitions that we'll talk about actually grade you on teamwork almost as much as getting the goal finished in the robot competition. And anytime we talk about building robots where a student takes a pile of pieces and turns it into something, that's building that confidence. It teaches them, I can make something from essentially nothing. Now let's talk about what separates our robotics program from a coding program. So when we talk about these, we talk about our STEAM knowledge and our academic practices. You can look at our chart here to see that our robotics program hits every one of these parts. We have our computer science, engineering design, physical science, coding, scientific practices, conceptual thinking, mechanical engineering, and mathematical practices. Coding doesn't hit all the same areas. The reason that robotics is such a robust program that is fully integrated with these core concepts is because of the physical aspect of building a robot. If you're only learning coding, you are not having any engineering work. You aren't interacting with the design. There's a big difference between telling a computer program go and seeing the child change a robot to tell it to go. The difference in a computer going go is a couple lines of code. A robot going go, that's turning on a motor, turning on a light, doing many different things that you can see in some of our examples from the video at the beginning of class. And we'll talk about throughout our program today.
And of course, coding is still important. It's not something that we can throw away. It's something that we still need to practice, but that is just one aspect of learning robotics. And we really build on what we know through block coding and Scratch and even Python for our more advanced students.
Absolutely. Thank you so much, Tim. Yeah, coding is still a core concept. It's a core program for students to learn, and it's really going to be building these conceptual skills. Robotics takes those and puts it together. So the difference in robotics and coding is more of a coding's very conceptual and robotics is very hands-on with some of that conceptual aspect. All right. Now, this is probably the question I get asked the most often is, when should kids start to learn robotics? We say 4 years old. That's when a lot of our students will start in our 101 program. Our 101 program isn't just for 4-year-olds, though. It's for anyone that's entering robotics and has no experience. When I say that, I mean, I have 3-year-olds in the class. It doesn't have to be 4. You can start early. I also have had 9-year-olds and 10-year-olds in the class that have never touched a robot before in their life. We like to break these programs down by skill level and try to keep you in an age group that's close to you so it's more comfortable. But at any age you can start. Don't be afraid to join a robotics class. In fact, we just had a design class where I had my youngest student in it was 8 years old. This was last weekend, and my oldest student in it was 47. So don't be afraid to join at any time. The students can start early. That was an online course. For our in-person robotics classes, we do stay the K through 12, though. If the parents want to learn robotics separate, please reach out to us. We can set something up. All right, next, Tim is going to come and he's going to talk a bit about some of the competitions. He is our head coach, and he's been doing a fantastic job bringing us quite a few trophies in this last robotics competition and getting us an invite to the state of Illinois' 4-H robotics competition. All right, Tim, take it away.
Thank you so much, Brian. Yeah, and thank you for giving us a quick introduction to what we mean by a robotics program and, you know, some of the benefits that we see our students getting and what I've seen in, you know, personally, my little brother as well. Okay, so once again, we will be having a Q&A session at the end of today. So if you have any questions, please feel free to put it into the chat box and we can come back to it when the time comes. Okay, so the first large competition that I'm going to talk about is FIRST Robotics. Now, I'm sure many students have already heard of FIRST Robotics. Now, they have FLL and FTC and FRC. So FLL is what we're going to focus on today. That's the first LEGO League, as opposed to the FTC and FRC, which are essentially high school only competitions. But of course, they're also FIRST competitions. That's why you might hear those names. FLL, the first LEGO League, is the only LEGO-based competitions. The other ones are more completely designing your own robots to complete some kind of game or task. The first LEGO League is the one where you see the picture right here. They have a map and you still create a little autonomous robot that has to complete a mission. Now, what sets first LEGO League apart from the other competition that we're going to talk about today is the World Robotics Olympiad, WRO. What set this apart from WRO is that FLL is also a research competition, like Brian mentioned earlier. Now, what I mean is students have to answer a problem. They have to work together and actually collaborate. They have to present on their research. Why does their idea work? And also present on what makes their robot design important, or why did they design it this way? So the actual robotics component of the FLL is only 1/4 of your final score when you are competing in the FLL challenge. So that is for ages 9 through 16. This is the only section that you can, compete where you go to state and then you complete at nationals. FLL Explore and FLL Discover are more discovery and exploration based, where you don't get graded. Or you do get graded, but you're not competing against anybody else. Rather, you're competing against yourself and your score that you've gotten before. So the FLL is way beyond just a robotic competition. You're also graded on how well you can work with each other, how well you can match your core values to the research, and how well that what you actually answer the question and you have facts to back up everything that you've talked about in your research, and whether or not your idea is feasible. These are all important aspects to getting a really great score. That's why we say these robotics competitions really help students, not only just learn the basics in coding and engineering, but really how to work with one another to solve a problem from such a young age. These are projects and competitions that students typically don't have access to until they're in high school or into college. But these experiences are very similar to those research projects that you'll have to do later. And this gives you a great head start into what it means to collaborate and what it means to really try to solve a problem for the community. So the next competition that I'm going to focus a little bit more about is WRO, or World Robot Olympiad. Now, this is the one that we competed in last year and the year before, and this is the one that I have coached Luke in as well. So Luke is our team captain for our robotics team. He last year he placed third in the WRO Robo Mission nationally. And he was, I believe we came in 27th at the World Robotics Olympiad World Championships in Germany last year. So this has been a great experience for us, and it has been a great experience for me to see the level of growth Luke has gotten to go through within the last 2 or 3 years. Now, unlike most of the students here, Luke didn't start robotics until 4th or 5th grade. So he was quite a lot older than most of the other students here. And he still achieved quite a bit in just that short amount of time because of his dedication. So that's something that I really want to make sure that the parents here understand. If your child is a little older, if the student is a little older, that's okay. It's okay to get started whenever you do. If you have an interest in it, try it out. So the Robo Mission is the one that you can see in the picture. They still have a autonomous robot that moves by himself to complete a mission and complete a task. So in this one, you're only graded on what's on the board, what's on the table, how well you complete the task. You are not graded on anything else. So this competition is purely on engineering, purely on coding, because the coding aspect for this is quite tedious. The first time Luke entered the competition, that we had a team enter the competition at all, essentially we had 0 points on the first couple of runs. Even though we could get it to run by ourselves off the field during the competition, for some reason, it just wouldn't run. It took us years of trial and error before we were able to figure out what exactly was wrong. And that's kind of why I'm so passionate about this. And I just want to share the experience that we've had through these last couple of years in learning how to best handle this kind of projects and these kind of tasks, and breaking it down curriculum by curriculum into steps that students can learn and absorb without taking so many detours, and having a clear pathway for our students immediately. So I am super excited to announce that this year we actually have the Robo Mission Redo categories. Now, this is a new category just for our United States group. But this will be a new mission that I'll show everybody the map in a second, but a new mission, Robo mission that just came out this year. And I hope that we'll be able to field a couple teams in, because I think that'll be a lot of fun. Now, this one will be a lot easier than the Robo mission for the elementary division. So the We Do division is ages 4 to 6, I believe. Yeah, 6 and under. But I believe they might be opening it up to 8 and 10, but we will contact the organizers to see if that will actually happen. Okay, so this year's theme is connecting the world. So the challenge is to make a robot that can transport and sort fruit from the garden to the different boats and collect different kind of essentially yellow and different colored balls from the different ports to the different harbors, from the islands to the harbor. So what I mean by is, let me see if I can get my annotation out here. Here we go. So these are placed on the ships, and you have a ball that you have to collect, that your robot would have to move between the ball and the harbor. So you had to transport between this, and you have bonus points between this and this as well, and bonus points reaching the floating market. So the easy part comparatively between the We Do Robo Mission and the harder elementary division is, once you get back to what they call the boxes, the 2 boxes right here, you can actually physically move your robot from this side to the other side. So you're allowed to change this way so that you're able to complete the mission directly without having to turn around and go to the other side. This is the easier way that they've decided to do We Do Robo Mission. Yeah, that just gives an idea of what these kind of missions look like. And this is the one for the elementary field. You can see it's a little bit harder with different colors. So essentially, there's a whale that you have to move back over here. There's a bunch of corals that you have to pull in here. This is what the corals look like. And then you have waste from the ships that you have to move back to the different colored bins so you can sort them to recycle. So of course, the elementary division is a lot harder, and it requires a lot more programming skills. That's why we have a couple of classes beforehand that we recommend all of our students to take, that we'll talk about in a little bit. But this just gives everybody an idea to what these competitions look like, and exactly, how involved some of these more advanced competitions are. Okay, so how do we prepare for competitions? Basically, we're going to split it up to these couple of simple things. You need to know how to design an attachment, how to design something to complete a task. That's why we have our We Do classes. Our We Do classes teach our students really what kind of attachments you can build with Legos and how that can function. So those classes are more instructive and more helping you realize the different ways that these Legos can be used. Our coding classes is what teaches you, how do we make this whole thing autonomous? How do we make it go completely by itself? Now, so we have a couple of basic classes in our Scratch coding, which we'll use mainly for our WRO and FLL teams. And then later on, if you do more of the advanced stuff, we do recommend they move into Python. So, of course, after you know those two basics, then you can form a team. Every single one of these competitions require you to have a team of at least two. At least two. So for WRO, it's 2 to 3 members. For FLL, it can be much larger. But the whole point is, how well can you work with another person? How can you learn to be a better communicator if you're going to be a team leader, or if you're going to be somebody responsible for a specific component? For us, we want students to be able to be much more well-rounded. I know some high school teams, especially in the FTC and even in the FLL, FRC, they tend to split, one person is responsible for robot building, one person is responsible for the coding part, one person is responsible for the business and community service aspect. That's not what we want. We want all of our students to be able to touch on all of these points, because we believe it is so vital to how they think and how they can really prepare themselves for any kind of challenge that they meet in the future. And with all of that, they will definitely do well in whatever competitions that they go through. And you know what? I think it's students learn so much for going to competitions. Of course, it doesn't really matter whether or not that they win, but going through that process really gives them the confidence to say, hey, I can do this. This is something that I've worked towards and I've actually done and I've actually accomplished. I know this is something that I've seen personally in Luke and how much he has grown through his experiences, not only in his successes, but in his failures as well.
Thank you so much, Tim. I wanted to add real quick that we form more than one team every year when we do this. So you're not competing for that 2 to 3 person slot. Our center will have multiple teams, and the kids will be competing against each other in local, state, regional, and possibly even national competitions.
Yes, thank you so much, Brian. So for WRO and for FLL, they start locally. We do have regional competitions. For WRO specifically, there's going to be a state competition before you can go to nationals. I know the last year, Luke and I were both at nationals in LA. I believe this year they're doing one in LA and one in Boston, I believe. And then the World Championships, one possibly the World Championship in Panama, and the World Invitational in Denmark, I believe.
So there's 2 international competitions this year. There's the 2 national competitions. There's multiple local competitions, and there's state and regional as well. And that's just for WRO. We were also just invited today to join the 4-H states Illinois competition. It's a different style of robotics competition that's a bit more open-ended and requires the students to be a bit more familiar with the robotics than some of these early level, like the We Do robots.
Absolutely. So this gives everybody a pretty good idea of how we structure our classes. So we start with, on the left, the Lego We Do classes. And like we mentioned earlier, and you'll see later in our graph, this is our introductory courses. Through this, students learn what can work. They're provided with a lot of direction and a lot of building instruction in the first We Do classes, especially in 101 and 102. In 103, students then are more challenged with complete a mission, complete a task, or with a much more advanced build that requires some programming to use it to as something that is a functioning tool. Now, with that, we recommend after students are completing it, or while students are completing the We Do section, to start learning Scratch for robotics. And the reason is the autonomous part of the competition is more difficult than most students would expect. Now, we've had a lot of members whose parents are engineers, are computer science majors, master's, PhD students that look at this Scratch and code and they're just confused on how does this work in comparison to the robot that we're using. They can understand the code fine, but when they're tuning it for the mission and to the specific attachment and how it works, they have trouble seeing how it connects together. That's why these Scratch for Robotics classes that we have offering are so important, because it really teaches students how we are using programming to move and complete tasks when we're competing or getting ready for competition. So for the Lego, we can form teams as well, like we said earlier, to compete in the WRO category. For the Lego Spike, now we have two series in Lego Spike, which is the more advanced version. Now, Lego Spike is a bigger hub. It can attach more motors, and it is the newest version of robotics that Lego has. So Lego has been getting rid of EV3. I know many of us are familiar with EV3s, but that is something that Lego is starting to phase out. Lego Spike is their new replacement for that. So we have classes based on that to prepare students for the higher level WRO categories and competitions as well. And once you get to the junior, past the elementary division, for the junior and senior divisions in WRO, that's when we really recommend you start using Python. And the only reason is it makes everything easier for you. So you really see the difference in how you can turn like pages of Scratch code to maybe 40 lines in Python. So students will be able to see that progression and really learn and still use the basics that they've learned through Scratch, but through Python, be able to use it even completely or more through, you can use it in Spike, you can use it in EV3. And with that, we can have students compete. So for WRO, usually our team members are, for elementary division, I believe you have to be 11 and under. For the junior division, it's 12 to, I believe, 12 to 14. And then the senior division is 14 and up for high school, essentially. Lastly, we have another great program, and that's the SumoBot program. Now, the SumoBot workshop is available through us, but we can also help. You with purchasing a kit. Now, we compete through the United States Engineering League and World Robotics Olympiad. So WRO hosts the SumoBot National Championships, and Luke, of course, is our 2022 national champion. So he is the reigning national champion, and he will be defending his title this summer. So hoping for great things from him this summer. So good luck, Luke. Then, of course, you can join our league that will be happening this spring. So we'll be having tournaments and league nights essentially every other week at our center in Bridgeport, and hopefully opening it up at the Montessori Gifted Prep as well. So these are the different sorts of competitions that your students can be involved in, and kind of the progression that we recommend students to do. Okay, so here is a chart to really see all of our classes. Now, like I said earlier, this chart is specially designed for students that may start from a very early age. It can easily be adjusted for students who are a little older but are new to robotics. So please don't be discouraged if you are a little older. I mean, like I said earlier, Luke didn't start learning until he was in 4th grade. So literally anybody can start to learn. We can do this. But really quickly, I'm just going to go over this with everybody. You can see through our We Do Robotics program, after you finish this course, even before you can look into doing the what we call the WRO We Do category, and after finishing these, or after 102. You can also go for the Lego League Discover if you're really under 6, but that's more of learning principles and building with Duplo rather than doing it with robotics. After that, that's when we recommend our Spike Robotics 201 and 202. before, and then making sure you're taking at least scratch 1 before competing in the elementary division for WRO, and especially the Lego League Explorer as well, because you really do need to have some programming basics to be able to start. And that's the same thing for our SumoBot program. We recommend you start at least around 8 or 9, just because some of the parts might be a little difficult for younger students. We recommend you be able to at least know how to use a small screwdriver, and some of the pins can be a little more difficult for younger students. But I mean, if the parents are willing to help, and that's of course that we did as well, it can be done for younger students too. At the last nationals, I believe the youngest student was 5, and he did very well in the Illinois State Invitational for SumoBots too. So yeah, parents are definitely able to help students when, as long as they're not completely designing the robot for them. So if anybody would like to see this or have a copy of this page, please contact us. And for our catalog as well, we'll have a link to that in the future. Or not in the future, in just a little bit.
Thank you so much, Tim. Very good. So now we'd like to open it up and have you ask us some questions, and we'll go through them. We have a couple of questions that came in through the chat and some that were submitted to me through email earlier today. Now, the first question is there a national competition from time to time every year? So there are national competitions. There's regional, local, and national, and state competitions as well. These competitions, you level into it. So you have to win the locals to get to the state. You have to win the state to get to the regional, from the regional to the national, from national to the internationals. Our teams have been invited to some higher level competitions. So like the Illinois state competition, you don't need to compete in locals. You don't need to compete in regionals. It's just straight to state. So there are some competitions we get invited to where we go straight to the higher level one. That's because of our high standing in the past. We also like to host a SumoBots competition on our summer expo night, where we will have students invited from all over. That includes a club we have at the Council Oak Montessori School, and that's a middle school age club, and they will fight with some of our elementary school students. And it's always fun to see how different the builds are in the SumoBots, because it's very much an engineering based robotics class, less focus on programming, more on creating a design that gives you some sort of mechanical advantage. And the younger students tend to have very different designs than our older students. Sometimes the more complicated is better, sometimes not so much. Luke still is undefeated. Like, no matter how old the student is that comes up against him, Luke's robot just keeps coming back.
For a SumoBot, yeah.
Yes,
Luke is it's going to be very interesting to see how this season goes. I see another question. Usually you just need an iPad, and that is correct. For almost all of our classes, especially for our We Do classes, excuse me, for Spike, even for the coding for robotics, you essentially just need an iPad or any other Bluetooth enabled tablet.
Yeah. Now, when you get to the higher level classes, sometimes you want to switch that over to a laptop because there is a lag with those iPads. For SumoBots, you really don't need anything. Just the coach has a computer where they control the program, and those you actually control through PlayStation 2 controllers, which is just awesome. Now, another question I have is, does everyone participate in one team? So the students will not be playing in one team. They will be split up into different teams, but they can join 2 to 3 people together in WRO. With our first competitions, the teams can get much bigger, but we like to keep the teams at a reasonable size so the students get a taste of everything. So I'd rather run 2 medium-sized teams than 1 large-sized team, because if I have a large-sized team, the kids don't get their chance to work on the robot. They'll be fighting with just time constraints there. So I like to have those multiple teams, give everyone the option. For The 4-H Illinois state competition, that is 3 to 10 people. So that is a very weird contest. It's very different. They don't give you a set mat. You make the robot, you make the mat. They just give you the rules. It's a very different type of competition. All right, I have some more questions. How young? 447. Beginners get started. Start with 101. Okay.
Yeah, that's a great question. And absolutely, we recommend starting from 101. We have students that have started 101 when they are just 3. We have students that have started when they are 8 or even 9 that have started 101. But we recommend students who are 6 and under, if they don't have any experience, to start with 101. If those students do have a little bit of experience with, building Legos at home or through any other classes, any other programs, and have learned a little bit of block coding, we can put that student in 102, and they can test in for some of the other classes as well. We do offer that option for students.
Yeah. Oh, I have a good question. Our locations, we do have more than one location. Our main center is in McKinley Park, Bridgeport area. We also have classes on the south side over at Montessori Council Oak, and we have Alsip Park District. We will also be at Montessori Gifted Prep in the north side.
Yeah, so importantly for our parents that are listening today, the 2 locations, once again, are the ones in McKinley Park, that's 1553 West 33rd Street. That's on Halsted and 33rd Street. And we will be partnering with Montessori Gifted Prep on the north side. So that's pretty close to, I think one of our other parents earlier, pretty close. They said to Seltzer Regional Library, where we used to have classes as well. So these will be our 2 City of Chicago locations that we will be working from.
Very good. Okay. Now, we do have a very fun announcement today as well. Feel free to send in more questions. And Tim, can you go to the next slide? So our nonprofit, the Center for Future Innovators, was just nominated for Nonprofit of the Year by the Blue Island Area Chamber of Commerce. So very excited about this. We just were informed of the nomination today. So please help us out. Scan the QR code and vote for us. Right.
We do appreciate that, everyone. Thank you so much. And we have another question. Do we have any classes available on Sunday? Yes, while most of our classes are currently based on Saturdays at our location in McKinley Park, we will be starting our Sunday courses at Montessori Gifted Prep. March 4th will be the first weekend we will be there. So we're hoping to fill up an entire day's worth of classes there. So if you know anybody or if you guys are interested, we will be having our physical open house actually this Sunday, but we'll be happy to have everybody and meet and talk with everybody later about that as well.
Okay. The schedule for the Montessori Gifted Prep. Yes, that will be being announced this Sunday because we have our open house at Montessori Gifted Prep. So you're all welcome to join us there, where students will get to have some hands-on experience with the robots and see our different programs up close and in person.
Yeah, but yes, like I said earlier, the ones at the Montessori Gifted Prep will be beginning March 4th. So that'll be the first week. So the registration for that will be open, and I believe Mr. Meadows or Brian will have that available to us afterwards as well.
Yes. Thank you so much. All right. Feel free to send in your questions. If you don't want to type your questions, you can go ahead and unmute and we can answer there too. Oh, how long are classes? Classes are 50 minutes long. That's enough time for the students to go through the module. But the most important part about our classes that set them aside for the robotics, we do 101, 102, 103. is that the students are not just learning, okay, these are the instructions to build a robot. This is the instruction to build the code. The students learn why this robot is being built. What is the function of this robot? What's the real life relationship here? So when we build a windmill in class and the students have to learn to program different intermittent frequencies and making it change directions, they're learning what was the first windmill created? Why is a windmill an important object to engineering? Right. Now, so our 101, 102, 103 classes are each 50 minutes long.
103, sorry, 103 is an hour long.
Oh, yes. Thank you so much. Then the spike classes will be 1 hour long. As we get to competition ready, those are more of open times for the students to come in to work on their robots. We have the times available for students to come in, and there's a class aspect as well. The classes are set times. Those will be hour-long classes, and then open build time to work on your competition robot.
Right. Unfortunately, right now, we do not have classes at McKinley Park on Sundays. That is something that we hope to be able to open up in the near future. But as of right now, we will only have Saturday classes on the south side and Sunday classes on the north side. Currently, almost all of our classes are in person for robotics. One of the reasons being if you would have it online, students would have to have their own kits, and I know that can be an investment for some parents and some families, but it is possible. We have done it in the past where we do have online classes where students are building and completing a challenge together, but virtually as well. But currently our robotics program is in person.
Yeah, our coding classes have taken place online in the past. So if they're very interested, but they're not in the area and they can't get there in person, then being able to learn at least the basic coding is a great first step. And those are very engaging classes where the students get to build their codes and the teacher gets to see as they build the code as well. So the teacher can give comments and show examples of how this code relates to the robot, or if it's just a pure coding class, how this code relates to your overall goal. Okay. Thank you so much for all your questions. Please feel free to ask more.
If everybody's a little shy, I have one more video I can show everybody. This is the last year's competition for WRO. So this was in Germany, and this was Luke's design. Everybody can see this. So you can see it moving the ladybug, cutting the grass, as they call it, collecting the red ones, cutting the green ones, collecting that red one, moving the ladybug aside, cutting the other green one. And we have one more red to collect. There we go. And we got to put all of those red ones into the box. Oh, I forgot. That's the challenge is taking them away. But moving that seesaw over there and moving all of those red things that we collected and taking them back to this section here. So that was the new challenge that was posted during Worlds. So that was the best run that Luke's team had during Worlds last year. So you can see that was completed in about 48 seconds. So the entire point, oh, you can see it go back home as well. So you have about 2 minutes to complete each task, each round, and that is your maximum amount of time. So you're graded on one, how many points you get, and if you get the tied amount of points, then how fast are you in completing it?
Good. Well, thank you so much for showing that for us, Tim. And it did bring up another cool point. These competitions will have surprise rules that come up. So that's why it's very important that the students learn these robotics fundamentals beforehand. Because if you go to the competition and you just have a robot that you learn to build by watching YouTube videos or by just copying the code in class, it's not going to be able to help you because they changed the game rules the day of the game. That's why at first we saw it went to that red zone. Well, the original rules said you drop off all the red blocks at the red zone. Day of the contest, they move the zone. You need to know how to change that in your program. And that is coach-free programming. Those are just the students. So that's why it's so important to build those fundamentals of robotics, starting with those 101, 102, 103. In those We Do classes, the students are learning not just how to build the robot, but they're learning the introduction to sensors, our motion sensor, our light sensor. And we have the color sensor as well, where a lot of that robot's movement is all based on sensor information, following the lines on there, being able to tell the different colors, because each of those blocks gets randomized at the beginning of every game. Where those green blocks are compared to the red blocks, the robot doesn't know because it could be anywhere. So it needs to use those sensors to detect where these things are going to go. All right. Any more questions? Wow. All right. It looks like there's no more questions. Thank you, everyone, so much. Thank you, Wesley, for voting. I just saw they voted for us. Yes. Well, thank you, everyone, for joining us today. I hope to see you in our robotics classes. And remember, Sunday, we will be at Montessori Gifted Prep. So that'll be a great time where you'll see all of our different types of robots that are available this season for students to use. So that includes our We Do. We'll have a demonstration of our WRO Spike Prime robot, and we'll have some sumo bots ready for the students to compete against each other. We'll have some other build sessions, and we'll talk a little bit about our Minecraft courses on Sunday as well. But thank you so much. If there's any other last questions, feel free to send them. I will be hanging out in here for a little bit yet. But thank you for coming today. Tim, do you have anything else to add?
That's it for me. Thank you so much. I appreciate everybody's time tonight. I know it's getting late, so we'll call it a day here as well. We appreciate everybody coming so late at 10 o'clock here for us Chicagoans. But you know, this is a time where most of us are still up, and it's great where we can talk more about the details.
Yeah. Thank you so much to our head coach, Tim He.
Thank you so much, everyone. And thank you so much, Brian, for being our wonderful host. And we'll hope to see everybody Sunday and in our classes and in our center in McKinley Park.